Okay guys, so welcome to the crazy paper foldy day. I gave you to print out a couple of things that aren't in your packet, right? So it's a little chart that kind of is going to keep up with everything, and also a sheet of paper that has 4 triangles on it. If you don't have access to a printer, then you can just cut out randomly 4 triangles. I would tell you though that if you're going to just cut out some random ones, try to make them acute, meaning that all 3 angles are acute, and also do your best to make it not accidentally equilateral. Like, I was very purposeful about how I did this, and the reason, without getting into a lot of conversation about it, is there are some special segments that if it happens to be equilateral will almost look like and kind of be the same thing. And so if it's something where it's like, you know, it's kind of got a longer line, kind of like maybe not right in the middle, but over a little bit, and then connect. Just try to make sure they're as acute as possible. It's like, to me, this looks like it's a right angle. I'm like, not gonna work. I want something higher, a little bit over to the right, boom, boom. You know, but like I said, if you have access to the printer, just try to kind of copy things that are about this size, because we're gonna write some things on it. If you would like to try another problem that is similar to the one in the warm-up yesterday, I put this up, so I'm going to go ahead and let you pause this video to do that. You'll also see this random thing up here. Did you know that crunchy peanut butter is always better? Oh, and also, can monkeys order apples? Like, I know they can order a banana because they usually eat bananas, but can they order an apple? And if you're like, what the heck is this guy talking about? It's okay, no worries, just don't even worry about it. Just know that crunchy peanut butter is always better. And yeah, can monkeys order apples? I don't know. Okay, so pause the video if you want to work out this warm-up. So this time, I didn't have any like isosceles things, but I know that all 3 of these have to add up to 180. So I wrote all that equal to 180. I did not try to divide by 4 in this first step because a lot of these things cannot divide by 4. But I knew I needed a factor, so I brought everything over carefully. When I got there, it was stuff that could divide by 4, so there's another opportunity to, reduce that equation. I then factored it and got 2 potential answers of -9 and 6. When I went to plug -9 in, I did get negative answers for angles, which meant it was gone. But 6 did work, and then when I plugged them in, I got 31, 31, and 118, and they absolutely did add up to 180. It's just like a check on that. So, cool beans done. I also had up the answer key to the homework, and I will point out, if you're watching this video, the teacher who made this answer key wasn't me. Okay, they made a mistake. They should have added this 12 to the other side and got that x equals 30, or they could have distributed, solved it through, but either way, the answer is x equals 30 on that one. I don't know if there's any other mistakes, but I did catch that one pretty quick. Thought I'd throw that out there. But again, if you have questions from here, let me know. The biggest place people tend to have issues with is this middle section, 12 through 15. As far as like needing to set them up for systems and solving them some way that you can figure out. There's a lot of different ways you can do it. I personally tend to order them all for elimination. Looks like some of the other teachers, set them up to do substitution. It's really up to you. You just have to find something that works and go with it. All right, so I want to spend our time on this little piece of paper that we got. We're going to talk about the different special segments, and then we're going to literally create them on these little triangles. So the first thing is a perpendicular bisector. Okay, perpendicular bisector. To give a quick sketch of what one of these looks like. Perpendicular bisector means you're going to cut this in half as best as you can with your eyeball right now, so those 2 things are the same. And then you're going to 90 degrees, just go straight up. That is a perpendicular bisector, okay? Cuts the side at a 90-degree angle, but cuts it into 2 congruent segments at its midpoint. So what we're going to do is create perpendicular bisectors for all 3 sides of one of the triangles that we printed out. So I told students to use you can use a pencil, but if you want to highlight in like 2 different colors, I'm going to use a very light color. Like, I plan to use like a yellow or like a green on the smartboard. It's the lightest color I have to like draw the connecting lines. And then I'm going to use a darker color or just a different color to highlight maybe new information I find out about that, and then just kind of write some vocabulary. So how do I find perpendicular bisectors accurately instead of being like, this looks like about the middle, and put a dot? All you're going to do, I'm going to try to get closer to you. You're just going to take any 2 corners you want, like here's 2 random ones, bring them until they meet, and you're not going to crease, you're just going to pinch, like pinch to find the midpoint, and I'll open it up. So you'll just have where the midpoint is, and then with your ID badge, a ruler, anything, cereal box, you're going to just line up. In fact, do I have my ID badge on me? Yes. I'm just going to take where that midpoint is, marking it off here, take where that midpoint is, take my ID badge, and line it up as 90 degrees as possible. So like, I mean, that's clearly not 90. If it's like really close, it should be fine for what we're gonna do. Just get it about as 90 degree as possible and trace that line. Okay, so what that should look like, generally speaking, is I found the midpoint by pinching my paper, and then I'm using something to try to draw 90 degrees straight out. What you're then gonna do is rotate your triangle and do it again. So whatever two corners you just did, just kidding, twist it, do it again. Bring the corners together, pinch, that's just to find the midpoint, open it up 90 degrees. Do that for all three sides. What you should notice, I'm gonna do it here again, just kind of doing my eyeballs for this. That's about the midpoint. Here's my 90 degree going straight across. And this one, I'm gonna try to eyeball my midpoint, 90 degrees, and go straight across. And if I've done this really accurately, which is not always possible on the smartboard, those should all intersect at a point. Okay. So I usually do some little bits of labeling. Maybe in the same color that I did these, I just write down this is perpendicular bisecting. So I just remember what I was doing when I created those. This middle point has a name. It's called the circumcenter. So I definitely wrote down like circumcenter to remember what the name of that special point was. And this one has an interesting feature about it. What does it do? It is a point that is equidistant from the vertices, meaning it is the same distance from all three of the corners. So what I would now do with your ID badge is from that middle, and this would be like in a new color, and I'm gonna use like red, I guess. And I'm gonna just kind of connect from here to my corner, from here to my corner, and here to my corner. And I wanna make a little note that these are all congruent. Okay, that is like the new information that I know about this. So it's made from perpendicular bisectors, it's called the circumcenter, and the new information I have in this new marking color is that all three of those are congruent. Okay, something I'm gonna have you write down on this paper is I'm gonna do a very fast sketch. In fact, I have it set up on this next page. Okay, so it looks like I did use yellow and then you did green. But anyways, but you get the idea. Perpendicular bisector is the midpoint and it's 90. And the thing that you're gonna write like in, on, out. And I'm gonna explain what those are and that they're not gonna be the same for all of these segments. So if I have an acute triangle, which is what we had on our paper, it is definitely going to land on the inside of the circle somewhere, which is why I gave you acute ones, because I didn't want this answer to be like off the page. If it's a right triangle, when you go to cut this in half and connect, cut this in half and connect, cut this in half and connect, all with 90s, it ends up being on the triangle somewhere as opposed to within it. And if you have a very open obtuse, when you do all these different 90 degrees, where they end up crossing is not even on the circle or on the triangle at all. It's completely outside. And an interesting feature of this problem is that the circumcenter can create a circle that would barely tap at each of these corners. And that was a thing we kind of previewed in yesterday's notes. And down here, I have just a quick visual of like an acute, a right angle, and an obtuse, that even when the intersection or the center of that circle is not physically within the triangle, it's still a circle that will just barely tap at those three places. Okay, so that's pretty much all the information you need to know about the circumcenter. Okay, the next one that we're going to create is the in-center, and it's created by angle bisector. So I'm going to pick up my new triangle. How I create an angle bisector, the goal is to basically get this angle split exactly in half and then just extend the line across. Now, I want to make sure we do that as accurately as possible. This one feels a lot like doing a paper airplane, where you just take any two sides and just carefully fold this until those two sides match up. Okay, we're more focusing on the fact that these match up here. I don't really care what overlap is happening here. On this side, doesn't look like there's a lot, but I'm really trying to just get that angle perfectly bisected. And instead of just pinching it like last time, you can actually crease this, because that will be the line that I want. It's cutting that angle in half and going all the way across. Okay, so that was with those two sides. So I'm going to turn my paper, and I'm now going to try to get these next two sides to line up. Again, it might seem a little awkward at first because you can tell on this one, you can see they're not going to line up perfectly. It's not like a real paper airplane where we're using a rectangle. But what I'm trying to do is just cut that angle in half by bringing it until these sides line up. Okay, pinch, increase, open it back up, and you should generally notice that you're getting your angle. Try to get the shadow right here. Angle cutting across. This angle is split in half, cut across. So there's one angle I have not yet pinched in half. So I'm going to fold these together like a paper airplane. Again, not super worried about what it's overlapping like at the back. I'm more worried just that the edges are the same. That means that this angle is being bisected, and do that crease. If I have done that extremely carefully, they should all intersect at approximately the same point, which is kind of right here. So do that, and I would now go in with like your ID badge and just retrace those lines with whatever your lighter color is, right? That was my angle bisector. This one's about half going straight across. This one about half going straight across. If I've done that perfectly and accurately, they will all intersect. I would make a note to myself that these are angle bisects. Okay, we bisected the angle. The name of this is called the in-center. And then in my new color, a special feature about this particular point is it is equally distant from all the sides. So it will be the same distance from the sides. Remember, distance from a point to a side is at 90-degree distance. So with my ID badge, if you want, trying to just connect these 90 degrees wise. And this one almost looks like it's already kind of lining up with it, just coincidence. But these three distances are the same, okay? So a just reminder of what one of these looks like. An angle bisector, again, is we try to kind of eyeball for this drawing, cut this in half, and extend across. Okay, these angles have been bisected. So it doesn't have to cut this in half because it could be hitting it at a random spot, but it's definitely bisecting it up there. Now, the in-center for all three of these, I'm going to go ahead and show you here. Oh, there's my pretty drawing. That for all three, whether it's acute right or obtuse, it's going to be inside always. And so I have a quick sketch of that. You're welcome to sketch that if you want, or just write down they're all going to be on the inside. But it's basically because of the way you're cutting the angles in half, it has to drive through the middle of the triangle every time, and so it always ends up on the inside. One interesting feature of that one we previewed yesterday was at this point, because these three distances are the same, if you were to set your compass onto this, it would make a circle that perfectly fits inside of the triangle. And the fact that the circle has to fit inside the triangle is part of the reason that its center will always be inside. Okay, whereas with the other one we just looked at earlier, this guy, because of the way that 90-degree can work, like it just acts different. We're going to notice that any of them that require a 90-degree, like some type of a perpendicular situation, are going to have the option to be in, on, or out, whereas the ones that don't require that all end up landing on the inside. So let's look at our next one. The next one, the point is going to be called a centroid. It's created by medians. And what is a median? A median is where we bisect the sides. So we find the midpoint. So it's kind of like perpendicular bisector. We find the midpoint. But now we're not going to go 90-degree. We're going to just connect it to the vertex across from it. Okay, now it may or may not look like I'm cutting the angle in half. That wasn't the goal. The goal is that this is cut in half. That is called a median. And if I do all three medians, it creates an intersection called the centroid. So in my next triangle, I need the midpoint again. So again, to find the midpoint is where we match up the corners, pinch, just to find the midpoint, but I'm not creasing because the creasing isn't going to help me. Then I do again the next one, two corners, pinch to find the midpoint, and the last two that I haven't done yet, pinch. And then what I'm going to do is, again, maybe with my ID badge, I'm going to go from those midpoints to the corner. So I'm not trying to go 90-degree like I did with perpendicular bisector. I'm just trying to connect it to the corner and connect that line. Okay, go to the next midpoint to the corner and connect that line. Okay, so when I try to do that up here, it's hard for me to do. I'm looking for this midpoint, looking for this midpoint, I'm looking for this midpoint, And my goal is to try to draw it to this corner as best I can. To this corner as best I can. To this corner or vertex as best I can. And if I do that successfully, again, they will all cross at a point. So I would remind myself that these are called medians. That this special spot in the middle is referred to as the centroid. Okay. What's interesting about this one was the other ones, right, we had they were the same distance from the vertices, or they were the same distance from the sides. This doesn't quite have something quite like that. What this is actually is the balancing point of the triangle. So now I didn't finish mine because I just did the pinches, but if you connect them all and you find where that center is, in theory, if you've done that perfectly, you could put your finger at that centroid and it'll balance your triangle. Now, I didn't finish mine, so obviously it's just going to fall because I'm guessing where I think it might be. But if I have the centroid correctly, it will balance. So that's something kind of just fun to be like, oh, wow, interesting. Okay, there's a ratio I'm going to have you write down on here that I'm not going to really talk about until we do the math on this on another day. But this is like a shorter, longer, shorter, longer, shorter, longer piece. There's a ratio that we're going to get into that connects these distances. So like if this distance happens to be x, this one will be double that amount. So however long this will be 2 of those distances. So however long this is, let's call it y. The other side will be 2 of those. And this one we'll call it z. And however long that is, this will be exactly 2 of those. And we'll get into that math and like how we have to mess around with that, particularly in algebraic situations. But that is something I would write down that we know about it. Okay, so here's my completely filled out one. Again, it's the balancing point of the triangle. We've got those ratios that I kind of talked about. This one will always be inside. Again, it has to do with the fact that we're finding the midpoint and connecting it to the corners. So it always ends up landing in the middle somewhere. And again, for any of these shapes, that would be the balancing point for that. I also pointed out that the ones that aren't always inside is when they have to use a 90 degree, and this one does not require a 90 degree. The last one is called the orthocenter, and the orthocenter is found by using the altitudes. And the altitude is also sometimes referred to as like the height of a triangle. And how I measure the height of a triangle is you start at the vertex and then you go straight down 90 degrees. Okay, that's how we measure the height. And that is not necessarily bisecting that angle, it's not necessarily bisecting the side, you know, it's just that's start at the vertex and go 90 degrees and see what happens. Okay, so honestly, this one I don't have to do any like special pinching for. I basically just take this, I put my ID at my vertex, I try to make sure it just looks as close to 90 degrees humanly possible, and I draw my line. Okay, turn it, put my ID at the corner, get this to be about as 90 degrees as possible, and draw my line. And if you do it successfully, you should see that all 3 match. So if I start here and then just drop straight down 90, if I take this one, this is kind of hard for me to do on the smartboard, straight across 90, that's really not 90, but we're gonna pretend. And then this one, 90 degrees is about here. Okay, yeah, I could tell this one I didn't draw correctly, so actually I'm gonna remove that one because, oops. Take that one out. If I take this one and attempt to hit this at a 90, again, if I do that on the little sheet of paper with my ID, it's very easy. This is the point where they intersect. So what are these called? These are called altitudes. So I'm just reminding myself this is an altitude. And that special point is referred to as the orthocenter. Oh my gosh, all these fancy vocabulary words. This one, I don't want to say it doesn't have anything special about it, but the one thing that it does is it does chop up a non-right triangle into nothing but right triangles, which does give me the option to kind of break it up into Pythagorean theorem style solving. There is no technical ratio like we saw with the centroid. There is no like equal distance to the sides, because like here is actually, if it's perpendicular, these are the distance to the sides, they're not the same. The distance to the vertices are not the same, but it is interesting that they all do cross like that, and it does have that name. So to show you the completed one, we start at the vertex and just drop to a 90, that's what an altitude is. And because it's one that uses 90s, this is the second one that will also land in different places, where if it's acute, it's going to be inside. If it's right, it's going to be on it. It is obtuse, and then it's on the outside, because when I try to start at a corner and drop 90 to find how tall this is, where these things end up crossing is way off the triangle. And this whole like cuts into all right triangles things, well, to me, on a regular right triangle, it's kind of useless because it already is. But we'll find out later that this special chopping of right triangles has some interesting features about them. I think that's the following chapter, so don't worry about that now. Here, it does split this perfectly into 2 right triangles, and here's probably the most helpful, where it splits it into the 6 different right triangles, but everything has a 90-degree angle in it. All right, so that's a lot of information, it's a lot of vocabulary, and you can practice kind of just making those and seeing how they work on your little paper. What I wanted to go back just briefly was that weird stuff I said at the beginning, like, hey, crunchy peanut butter is always better, and can monkeys order apples? Okay, it means absolutely nothing, but what it is a silly way that I try to organize vocabulary. Crunchy peanut butter is that the circumcenter is perpendicular bisectors, and is always better is in center is the angle bisector. So the 2 bisector ones are organized in that sentence. So crunchy peanut butter is always better. Circumcenter is perpendicular bisector. In center is angle bisector. And then can monkeys order apples? A centroid goes with the median, and the orthocenter goes with the altitude. Now I will point out there are 2 with the letter C in it, centroid and circumcenter. I will try to tell you that I sort of associate the word centroid, it sounds a lot like central, and medians I think is like in the middle. So like in the center, in the middle, I kind of have a connection for those 2 in my head already, so I remember that that's the C word that goes with it. I've seen some people tell me that circumcenter is the one that allows you to draw the circle all the way around the outside, and this sort of reminds them of the word circumference, and it has that kind of outside drawing. The in center is the center of the circle is on the inside. So there's different ways you can try to sort of memorize them, but that's just to kind of help you have something kind of funny to think about. Now, I know it's like the Friday before break, and I'm not trying to give you like real homework, but what I would like for you to do to sort of reprocess everything that we talked about, the very first page, other than the learning targets, but it's labeled as page 1, it's basically a chart with all the same information that we wrote on our separate sheet of paper. Ooh, excuse me, lunch. And I want you to basically recreate it. So I have just an example of what I'm meaning for that, just so like we're clear. So like in the chart, it says, hey, what's the name of one of these special segments? Well, you're gonna say, we're gonna call it, it's a perpendicular bisector. What is important about that perpendicular bisector? That it starts in the middle and that you have to make a right angle. It does not have to include the vertex. What's the name of all of them when they cross? The circumcenter. Is there anything new that I know about it? Yes, the fact that it's equidistant to the vertices and it has that like in on out connection. Here's a singular picture of what one of them is, and then sort of a diagram of everything. Now that's like all the stuff, but even if you just wanted to show the perpendicular bisectors, you could just show that. You could show that it's equidistant to these sides if you want. Heck, you could draw the circle around it if that makes you happy, right? But it's a place to kind of reorganize everything we said. It'll just kind of force you to process it one more time. Okay, so good luck with all of that. It's a lot of vocabulary, so focus on knowing those vocabulary words. We're going to have a whole long break over Thanksgiving break, and when we come back, we're going to start dealing with the math of all of these. I am going to tell you on here, just to see if you actually are watching the videos, lucky you if you do, that for the chapter worksheet, I'm actually cutting off questions 5 through 15. There's nothing wrong with the questions. They're not necessarily that they're difficult. Just the wording is a little goofy about like what they wanted. Because like, hey, if I know this, what else do you know? There's like a lot of things I could write down. So I didn't feel like the answer that we were looking for was super clear. And So I just, like I said, cut that section. But there are a lot of good vocab practice on here. There's some math that like maybe you can feel like you're able to start. Maybe not all of it, because some of it we have to teach you still. But there are some things on here that you could potentially do to get started on that. But anyways, I'm going to let you go. And if you watch this video, good luck to you. You don't have to do a huge chunk of the chapter worksheet. And if people don't watch the video, that's on them. And what? Crunchy peanut butter is always better. And can monkeys order apples? Is my geometry teacher crazy? Yes.